Haug talk is on MLOps Adoption in the manufacturing industry, a case study with Zeiss SMT. Everything's there already, so the stage is yours, and please continue.
Then I use this one. Okay, then maybe let's start off with a quick motivation. Despite continuously high interest in machine learning based applications, we still don't see many production deployments of these applications. And one way to maybe combat this issue is to use machine learning operations, that is extending DevOps from conventional systems to machine learning systems. But doing this, adopting MLOps in an organization involves many options, many decisions to make. Which process do you follow? Do you use some kind of maturity metric? Which of the 15 different metrics that are defined do you use? What kind of reference architecture do you follow? Which components do you use? Which tools do you use to implement these components? Which components do you implement yourself? Which do you use off the shelf? There's a lot of variability here, and practitioners feel they lack guidance, and they may even feel overwhelmed at this thing, faced with this plethora of options. So our study is looking a bit at how do companies and practitioners adopt MLOps, and we were looking at the challenges, the solutions, and the impact of machine learning on the software architecture in one specific company, Zeiss SMT. To do so, we followed this process. We started with a preparatory phase where we prepared all of this is an interview-based case study. And in the preparatory phase, we prepared our interview guide. We also got our study approved by the employee representatives of the case study company. And we recruited our participants, obviously. Then we moved on to the interview phase, where we conducted semi-structured interviews. We adapted the content of these interviews to what people were telling us. So if something wasn't relevant for a participant, we skipped follow-up questions. On the other hand, if something was very important for our participant, then we dove deeper into these topics. We recorded these interviews and transcribed those, first automatically, then doing a manual proofreading pass to filter out any mistranscriptions. And then we moved on to the approval phase, so we sent the transcript to the participant, asked them to review, correct, and approve the transcript to us. And then we used these approved transcripts in our analysis, where we extracted relevant passages and performed open coding on these. So we assigned a label to each passage. And then we discussed these labels in the research team, came up with a consensus set of labels. We defined what these labels meant. And then we also counted how often they were mentioned in the article. Before we dive into these labels, let's have a look at how many people we were talking about. So we were talking to 12 people. Since these two were one interview and these two were one interview, so there we only had 10 interviews total. And since sometimes it wasn't quite clear which statements inside an interview people agreed with or not. So we weren't sure for these two interviews whether both participants supported all statements made by the other participant. We only counted interviews, not counted by interviews, not by participants. And regarding their self-reported experience, we see that most of them have quite a bit of experience with software engineering and also a bit of experience with machine learning. Not so much with DevOps and almost none with operations or MLOps. This is all self-reported, so take it with a bit of grain of salt. Regarding the actual interesting stuff, the challenges. We have 13 challenges and we have a wide range of mentions. So on top near universal, 7 mentions of data accessibility, which in detail means everything that has to do with getting a data set to perform your ML project. So this starts with identifying whether there is an appropriate data set, and then identifying who is responsible for the data set, and gaining access. And then also during the project, working with this project, with the data securely. So, for example, some projects or some data sets were not allowed to upload to the cloud. Yeah. The second problem was more on organizational side. Project stakeholders, for example, management or users, were not really familiar with the properties of machine learning, and that caused some friction with the more experienced developers. So this had two dimensions or two directions. One way was if people came, or a lot of people at Zeiss come from a physics background, so they're used to hard rules, and they have difficulty coping with the stochastic nature of machine learning. So for these, they distrust any machine learning based solution. And on the other side, we do have the people that treat machine learning as a silver bullet, and everything and anything must be solved using machine learning, and an algorithmic solution is no good unless it's some kind of machine learning algorithm. Both of these obviously are not really efficient when evaluating whether a solution should be, whether problems should be solved using machine learning. The third problem, heterogeneity. We heard it this morning already a bit. So in a machine learning project, we do have a very diverse ecosystem. We have a lot of frameworks, we have a lot of tools, and these variety and multitude of tools also reflects in the projects. So every project is free to choose tools and technologies, so all of them do, and if you have to switch between projects, you have to learn a new tool, you have to learn a new framework, and since most people are working on multiple projects, this also is less efficient for them. The third problem was that due to the restriction on using cloud offerings, a lot of people had to work with on-premise available toolings, or tools that they set up directly for the project. And this isn't as mature yet as cloud offerings, and also not as user-friendly. So here they also were feeling some pain. This much for the challenges. Now to look at solutions. Again, we had 13 solutions, and we see that a bit less mentions, but this is probably due to the relative immaturity of the MLOps process at Zeiss. Also looking at a few in more detail. So for the first three, these are kind of a fallback hierarchy. People are employing a cloud ML platform wherever possible. If that is not possible, they fall back to on-premises tooling, especially centralized solutions in on-premises, so that they don't have to implement everything themselves. However, some use cases even cannot use centralized solutions, so in this case they fall back to the sidecar pattern for model deployment, which means they run the model next to the, on the same machine as the rest of the system, next to the system that's using it. And the next big aspect of solutions, or the next big solution step, was to standardize many things, especially having a guideline that new projects can follow to establish their project, and then also having a template that uses follows these guidelines, so that like the 80% case is covered, and if you have special requirements in your use case, then you deviate from the template. And people would like to extend this even further to cover successful, or to cover experience reports from successful projects. The third question was, how does integrating an ML model change the software architecture of the system? Here we have a 50-50 split. So the first half of people were not yet at the stage, so the project wasn't mature enough to answer this question, or they were working on standalone or greenfield applications where there was no existing software architecture to consider. For the other half of people, they said, well, our architecture is already sufficiently modular, we don't have to change anything. However, in two cases we also heard, okay, we don't have to change the system architecture, but at runtime we do have new hardware constraints, so we need GPUs, or we need to have some kind of cluster application to execute our system. Looking a bit more deeply into the relationship between challenges and solutions, and also between the challenges themselves, we see that the main the fundamental issue here is the trade-off between security, as embodied by the data classification, and usability, as embodied by the cloud platform that people would prefer to use. Currently at Zeiss, we tip a lot towards the security dimension, so we feel the issue in usability. And people also voiced the opinion that a lot of data classification is too conservative, so people classify something as secret because they don't want to have any trouble later on when it turns out that maybe less strict classification would have been wrong. This gives us two ways forward. So on one hand, we can educate or force people to classify less strictly and to allow more data analysis in the cloud. On the other hand, we can also go in the improve the on-premise platform to have to handle the or improve the usability and to be competitive with the cloud platform. Some threats to validity of our study. Of course, since we're doing interviews and since we're doing qualitative data analysis, all of this can be highly subjective. However, when we have multiple mentions of something, then there's probably something there that's not really subjective, but there's a deeper issue. So if there's multiple mentions, then that mitigates the subjectivity somewhat. And of course, the whole analysis was done by a team, so also no impact of subjectivity there. We could also have missed some results, or have incomplete results, because either we missed some participants, or the participants didn't say something in the interview, either accidentally or intentionally. Regarding missing participants, well, our research team from Zeiss, or the team members from Zeiss, are well connected. They usually know the people that are working on these use cases because they are themselves involved in these use cases. So from this domain, or from this side, we don't see any problems. Regarding omissions, we guarantee participants' confidentiality. So outside of the research team, nobody knows who of our participants said something. And also every quote or something, of course, is approved by the participant first. So that should help reduce intentional omissions. And regarding accidental omissions, we gave them the chance either once at the end of the interview and also during the approval process to fill in the record, so to amend their statements. And another problem, since this is a case study with a single company, generalizability may suffer a bit. However, a comparison with the literature shows that these challenges are also relevant outside of the Zeiss SMT context. We didn't find any comparative studies with other manufacturing companies, so that would be a valid or an interesting scope for future work, comparing how these results hold up in other manufacturing companies. Which already brings me to my conclusion. So we conducted an interview-based case study on MLOps adoption at Zeiss SMT. We collected 13 challenges and 13 solutions from 10 interviews involving 12 participants. The key challenge is the trade-off between security and usability in MLOps infrastructure. In the future, we would like to improve the ML infrastructure on premises at Zeiss, and we would start to create this MLOps guide that people wish for, and that would hopefully also transfer outside of Zeiss. And as I already said, we would like to compare this with other manufacturing companies to see how well these issues and solutions hold up there. Thank you.
Thank you very much. This mic really trains you for doing more singing in karaoke. This is how you have to hold it, then it works. Okay, so thank you very much. Is there a question? We are so good in time. If there is a question, we could take it. Otherwise, if there's no question, think about it and come to the poster session. So thank you very much, Markus. And we will continue with our third talk of this session. And other than the program says, it's not Filippo from La Sapienza, University of Rome, who's giving